4.4, graphs of sine and cosine functions. So pretty much all of this week we're going to be graphing trig functions. And then most likely after that we'll have a quiz on those two, basically 4.4 and 4.5. So it could be Friday, maybe, so just be prepared for that as a possibility. The short week, it may not be, but anyways. All right, so we're going to be just jumping right in because you obviously should have had notes about graphing. We are going to actually be graphing the functions. I think we kind of did that last year a little bit, but since you have to be able to graph them on the exam, we need to make sure that you can graph them now. So this is just an example, but f of x is equal to 3 sine of 2x. So basically we have like 6 steps that we're going to go through. You don't have to like write out step 1, step 2 and all of that. I'm going to on these first couple at least to like make sure we get all the information. If you like this method, you can do it, but if not, as long as you know what's happening, you're good. So step 1, we're finding the amplitude, which is the absolute value of the number in front. So remember we have a and then the sine of bx, I think it's plus c, I don't know, it doesn't matter, and then plus d, this actually might be a minus. Anyways, but the shifting happens the same way that it does with like normal things, but the absolute value of a is 3, so I'm going to do it this way, is the absolute value of 3 is 3, so that's going to be my amplitude, so that's the height, like the distance from 0 on the graph. Step 2, we have to find the period of the function, and so that is the formula 2 pi over the absolute value of b, and so that would be 2 pi over 2, which in this case is just pi. And then the next thing we want to do is we want to find our like increments of how we count, because then it just follows a pattern. And so step 3, to find our like increment values, we take the period value that we found and we divide it by 4. And so this is just going to be pi over 4. So that means every value on our x-axis is going to be an increment of pi over 4. And one full cycle goes from 0 to pi. So then in this case, basically steps 4 through 6, I don't have any shifting happening, so I can skip this. So there are no shifts and no reflections.
What was shift number 3 again?
Step 3?
Yeah.
It's to find the increments of the like x-axis.
Oh, okay. Thank you.
Let's see. Will the grid
Can I
lines...
ask you a question? You just did.
No.
Okay, that's another one.
That's another one.
Just did. Okay, I asked an unlimited amount of questions.
Please no.
The first, like, in our notes, I was really confused about this when I was writing it. Like, the first formula is a sine bx plus c plus d. And then, like, a few minutes later, it's a sine bx minus h plus k. So it's like, why is the sign different if it's just different letters?
So I think the book uses h and k as like their values. So like if you remember when we did like parabolas, like there was h and k that was used. But I've converted to using c and d. Those notes might be from before it was AP. That might have been. So AP uses A, B, C, and D. So I've tried to switch everything to A, B, C, and D.
Okay.
But I just haven't switched that. The signs of them really doesn't matter. When it shifts, the C value is, do not pop that.
Oh.
The C value goes opposite the direction of the sign, left and right. The D value goes up and down the same direction as the sign. Yes, Ryan.
I can water with us.
All right, so I'm going to set up my graph. I'm going to, like, put this over here. Now, I I just made that way too big. I don't care. You're going to notice the book is probably going to tell you to draw like 2 full cycles. We're just going to do 1. Okay, on this one I might show you something with like in the negative direction just because it may come in handy. But as far as like you actually doing your problems, just graphing 1 full cycle is fine. Yes.
I guess I can make it water as well.
All right, so amplitude is 3. So I'm going to put 3 on here. Like this. And then the increment values, I'm going to go, just so we can see the graph a little better, I'm going to go every other like space. So pi over 4, pi over 2, 3 pi over 4, and pi. Now, I'm just counting. This is 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4 is how I'm getting that. And then we have to pay attention to, is this sine or cosine? Yes.
Wouldn't it be negative 3 on the bottom? Or is it not because it's...
Yeah, it is. So we've got a sine function. It starts at 0. Oh, this is throwing me off because it's not up here. Putting it back up here. Okay. So it starts at 0, and then it goes up. So it goes up to here, back down, down again, and then back up to the midline. Okay, so 1 full cycle would look like this, where it starts and ends like in the same spot. Okay, now if I wanted to go in the negative direction as well, like if my graph, let's say, shifted over to the left and I wanted to do something with that as far as writing my increments, I'm typically always going to keep it in that first like group of spots on the right hand side. But just be aware that if it was shifted to the left, I would also need to put the negative increments. They work the same way. So over here, this would be negative pi over 4. And then the next one, how long does it take him to get water?
I think he slipped. I think he's drowning.
And then negative pi over 2.
That's weird having on trying up. About Tristan's pants. I had to be an example. What?
I'm like, Shepard's in here dying of thirst, and you're
No,
out
he's
there
not.
taking forever.
It's just dramatic.
I was just kidding. So if I were to continue this graph, though, it would go down here, and then it would go back up to the midline, so just be aware of that, okay? Anytime they're talking about the midline, Zach, put that away.
I was turning off the ringer.
Oh,
I heard it.
okay. Anytime that it is, they're talking about the midline, they mean where this is, that whole thing is what's going to be shifted up and down and so on and so forth. Anyways, there's that one. Next one. G of x is equal to negative 2 cosine of 1/2 x. So, step 1, we find the amplitude, which is the absolute value of a, so the absolute value of negative 2 is positive 2. Step 2, we're going to find the period, which is 2 pi over b. So 2 pi over 1/2. And it's the absolute value of that. There's usually not a negative inside, but there could be. So what would that be equal to?
4 pi.
4 pi. Step 3, we take the period and we divide it by 4. So 4 pi over 4 is just pi. And then, again, there's no shifts happening, so basically step 4 and 5, there's no shifts. And again, I'm not normally going to write that, but since we haven't had one yet that has that, I'm just writing it out. But this one, step 6, is reflected. Okay, so that means this one's going to be flipped upside down. I'm going to try to do this over here. So again, I know I don't need to go to the left, so I'm just going to draw it this way because it's not being shifted. So I'm going to put the amplitude on here. And then increments of pi. So we've got pi, 2 pi, 3 pi, and 4 pi. So I'm always going to start out with what the baseline graph would look like for the given situation. So I'm not going to deal with it being reflected until the end. The only thing that I'll kind of do simultaneously is the shifting I may do. Once we get a little bit more experienced with it, I actually will often go ahead and do the reflection right at the beginning because I just know that instead of starting at, say with sine at 0 and going up, I know it starts at 0 and goes down if it's reflected. But if you feel like you need to do it in steps, that's fine as well. So I'm going to go ahead and graph this one without the reflection first. So I start, it's cosine, so it starts at 1 or the amplitude value, so it starts at 2. And then it goes down, down again, and then back up. So this one kind of looks like a V. And always draw your arrows turned like back around going down on these, or like with sine, make sure it's going like up opposite of, show that it keeps going with the arrows like that. So now reflected, we take every single point and we flip them over the x-axis. Okay, now the ones that are on the axis, because this graph isn't shifted at all, are going to stay on the axis. So the only thing are basically the ones above and below the line are going to just swap places with each other. So, find another color.
Yes.
I don't know where all my... I don't know. Anyways, so this point goes from up here at +2 to down here at -2. Then we have this at pi. That one stays. This one that was down here at -2 goes up here to +2. The one at 3 pi stays. And then the one up here at +2 at 4 pi goes down to -2. And then my V just goes basically the opposite way. And so if you put them both on here like this, like if you get really good, you might be able to do everything at once. I caution you from doing that because people tend to get things wrong. But you need to put an arrow here and write final. If you're using different colors, then you can just write the word final in the same color. I don't care. I would say be really careful using multiple colors because if you happen to put a point in the wrong spot, then you kind of like got to start over or grab some white out or something so that it's not like points like randomly all over your graph. Okay? Questions about these before we get into ones that have shifts to them? Cool. And you're probably like, why is she doing so many examples not out of the homework? Because the homework doesn't give a lot of good examples of them actually being shifted. So I'm trying to make up for that by doing other ones. So just letting you know. All right, h of x equals 3 times the cosine of x plus pi and then plus 1. All right, step 1. What's the amplitude? 3. Period. How do I find that? Step 2. Which is, yep, so 2 pi over 1 just ends up being 2 pi. So then I need to find the increments. So step 3, we take and we do 2 pi divided by 4, just increments of pi over 2. Step 4, so we haven't had this yet. This is our C value, okay? This is telling me what's happening. So C is equal to pi. It's positive. It goes opposite the direction of the sine, so that tells me this is going to go left pi units. Something to be aware of with this is going left pi, but notice my increments are pi over 2. So it's technically moving everything over 2 spots. Okay, so make sure you really pay attention to that. That's why having the increments on your graph is going to be really important. Step 5, this is for D, which is the stuff outside the parentheses. This is a positive 1. And so this goes up 1. So it goes the same direction as the sine. And then step 6, there's no reflections. So I'm not going to write it this time. We'll just do that. So normally if there's not something, I don't write anything. I just was doing it on these first few. All right, so I'm going to set up my graph here. Now, I have an amplitude of 3, but I know it's going to be going up 1, so I need to make sure I have room for that to happen as well. So on my axis, I'm going out to 2 pi, increments of pi over 2. Now, I know that I'm going to be going left pi. I know I don't need to go farther than left pi, so I'm going to go to negative pi on the left side. So I have my graph set up. All right, so this is cosine, so where does it start?
Up at 4.
3.
3. Starts at the amplitude. We're going to shift it afterwards. It will ultimately end up there. All right, so at 3, and then it's going to go down to pi over 2, or to 0 at pi over 2. And then at pi, it's negative 3. 3 pi over 2, it's at 0. And 2 pi, it's at 3. So this is my, basically like my parent function for this particular graph. Okay. Now, do y'all think you can follow if I do both translations in the same step?
Yes.
Okay. All right, so every single point is going to basically go left 2 spots, okay, because it's a pi, so make sure you pay attention to that. I'm going to tell you something that's really frustrating about this book is that sometimes it goes like left 3. Okay, like instead of this being a plus pi, this might be a plus 3. Okay, that's close to pi. Okay, so you have to know like pi is 3.14. So kind of get like that. What is that decimal close to? I'm not going to get a ruler out and measure it, but I'm going to tell you most of the time when you're dealing with a problem, they're going to give you ones that like you actually can put that value on there as far as like AP stuff goes. But I just want you to be aware in the event that it comes up. The situation where you're more inclined to see it come up is in that word problem as part of the AP exam. So that's why I give you a couple. But anyways, just be aware of it. All right, so every point is going to go left pi, so 2 spots, and then up 1. And so this first point here is going all the way over to negative pi and up 1. The next point is going to negative pi over 2, and it's going to be up at positive 1. The point that was over at pi is going to 0 and up 1. Point that was at 3 pi over 2 is going left to pi over 2, up 1. And then the point that was at 2 pi is going left to pi, up 1. And then we can connect it. And again, make sure you put final on here so that it's obvious of which one you're looking at. So do we at least kind of remember these vaguely? All right. We're going to jump into some actual problems. We'll have probably one or two more that we're actually graphing. I'm not going to graph all of these ones that aren't shifted because that's not really going to be helpful at this point. I'll graph like one or two more that are getting shifted as well. But these first few of your actual homework problems, they tell you that they just want you to basically state the amplitude, and the period of the graph. If it's shifted, they want you to tell that it's shifted or like reflected. None of them are shifted. So just, anyways, be aware of that. At least on those ones. And like I said, these ones we are not graphing. So number 4 is y equals negative 7 over 4 sine of x. So what's the amplitude?
7/4.
Yep, 7 over 4. And what is the period of this one?
2 pi.
Yep, 2 pi. It would technically be over 1 because there's a imaginary 1 in front of the x there. But obviously you don't need to write that part. Is anything else happening to this? What? Reflected. All right. Bless you. 8. Y equals the cosine of x over 5. So what is the amplitude of this one? 1. Now, for the period, something you probably know this, but I just want to point it out. The cosine of x over 5 is the same thing as the cosine of 1/5 x. Okay? So just watch for stuff like that where they put it in the denominator. So that means b is 1/5. So how would I find the period for this one? Yep, 2 pi over 1/5. Then we get to do Shepherd's favorite thing,
You change flip.
which is
Keep the 10.
no,
top
sorry.
line.
What is it equal to?
Oh, keep that 2. Flip the 1 over 5, 10 pi.
10 pi. Is anything else happening to this one?
No.
Nope. Nice and easy. The next ones, these ones say to sketch. We're not going to sketch these ones because, like I said, I want to spend time doing ones that are like being shifted. So, but these ones also want you to find, on top of the stuff we were just finding, they want you to find the frequency, which is b over 2 pi. Okay. So this is not like, you don't really have to do this part for part of the word problem trig graph on the AP exam, but they could ask you for frequency as part of a multiple choice question. So that's why we're going over this. So y equals 2 cosine of x over 3. The other reason we're not graphing these ones is because they have a like specific quote unquote window they want you to graph it in, and it just makes it excessive. So, all right, what's the amplitude for this one? 2 period.
6 pi.
6 pi.
Yep, so 2 pi over 1/3, which is 6 pi. And then the frequency basically just flips this over, but it's 1/3 over 2 pi, so b over 2 pi, which would give me what?
1/6 pi.
Yep,
I did.
1/6 pi. In case you need a refresher, when we have something like this is the same thing as 1/3 times 1 over 2 pi. In case you need a little multiplying fractions refresher. y equals -4 sine of 2x over 3. What's the amplitude for this one? 4, period, or how do I set it up? Either way.
2 pi over 2 pi over 2 over 3.
Yep, which will end up giving me,
6 pi over 2.
which is
3 pi.
3 pi. Keep change, flip, 2's will cancel. I'm left with 3 pi. And then frequency, we flip that over, so we get 2/3 over 2 pi, which is, yep, 1 over 3 pi. Is anything else happening to this graph? And it is reflected. So like I said, frequency isn't telling us anything as far as the graph itself. Well, I mean, it does tell us stuff, but we don't need anything with frequency to actually graph the function. The next one say to describe the transformations required to obtain the graph of y2 from the graph of y1. So these are really good because this will kind of lead us into some of those word problems and things that you have to do as far as solving those. Probably, maybe not tomorrow, but probably by Thursday, I will show you what those trig word problems look like, as far as like the graphs of them and stuff like that, so you can start to get a feel for it. We'll spend a lot more time on that closer to the exam because that is a guaranteed 100% going to be on the exam question. So if you can guarantee yourself 6 points right there, you only have to earn like, I think 15 other points on the exam and you pass. Okay? Like it's
What, on the AP or
How
Yeah.
many points are there total?
what, like 50?
each multiple choice is 1. Each free response is 6, I think. So 24 and I want to say it's like 64. So I think there's about 40 multiple choice questions. But in the ballpark of 20 points, you pass. Unless they've changed the scaling. And it's a little bit different. Like, I have several different practice tests, and the range is all a little bit different. But if you can guarantee yourself about 20 points, you should
What is
pass.
20 points on the scale of 5?
A 3. 3 would be the equivalent of a C, which is passing. Now, some colleges don't take 3s, so you have to know, like, if you have an idea where you're going, what they'll take. But it's, 3 should be feasible for everyone in here. So, anyways, but I say all that to say we're going to spend closer to the exam, we're going to spend a lot of time on those word problems, that one specifically. So we'll do a lot of examples. So I'll probably get 1 or 2 of them shortly that we'll go over within the next week or so, so that you start to see it. But we'll spend a lot more time on that closer to the exam so that you can guarantee yourself 6 points. Okay. So, anyways, all that to say, jumping down to number 50.
That's a big jump.
Yeah, there's a lot of them in here that are like, tell what the amplitude and period is of this function. That's pretty much the first 48 problems.
I feel like you should only do that.
And that's excessive. Well, you could just do that and then you would not do well on the exam, so. All right, y1 is 2 times the cosine of x plus pi over 3. And y2 is the cosine of, let me do this way, 2 times the cosine of x plus pi over 4. I modified this problem slightly because of what it was to make it more realistic. So I need to figure out what is happening to get from the graph of 1 to the graph of 2. Okay, so amplitude's the same, period's the same. So what's the only thing that's different about these two graphs?
Shifted left and right.
Yeah, it shifted left and right. So which what has to happen to get from 1 to 2? Think about in terms of if you plotted this on your graph.
Add 1.
Not 1.
Add
You move to the right.
It would probably be beneficial to get a common denominator and see how far we're
Right.
going. Okay? Sometimes that's going to happen. I'll tell you, most of the ones as the word problems, you're not going to have to like get a common denominator to figure it out. You'll be able to see it. But with this one, we would probably want to get a common denominator for it. So if I did that, pi over 3, what would the common denominator be? 12. So what would this be as something over 12? Yep, 4 pi over 12. And then what about this one? Pi over 4 as something over 12. So what's happening to get from this one to this one? Yep. So we move it left pi over 12. Okay? Because it's going from over here to the left.
So the whole point of that question was to like spot the difference.
Basically. These aren't as good as the like doing it as part of a word problem. I just kind of wanted you to see that like some of it is you may have an equation that's set up and you have to figure out how to shift it. Some of the other things that go with that are, it's hard because I don't have one to show you, but would you agree that like sine and cosine are the same function, just one is the shifted version of the other one?
yes.
Yeah, like I can just shift it over and they would line up, right? So the other thing you have to watch is part of the instructions for that particular problem is going to tell you to either use sine or cosine. So your temptation might be to use one of them because you might be like, oh, well, it started at the amplitude, so I know that it's cosine. But what might have actually happened is they might have told you to use sine and they want you to show that it was shifted. Okay, so things like that are what you're going to be looking for. So this isn't a great problem for this. I just, want you to see that. We'll obviously, like I said, get into more of that as time goes on, but let's just try to graph another one here real quick. Do y'all want to graph? Do you want me to graph another sine or a cosine one?
Doesn't matter.
I like sine.
Sine. All right.
Sine doesn't look-
All right. Well, we'll go with 62 then. This will probably be the last one unless y'all have a question. So we've got y equals negative 3.5 times the sine of 2x minus pi over 2 and then minus 1. So what's the amplitude of this one? 3.5. The period of this one?
1. And then 2 pi.
Yeah,
2 pi over 2. B is 2. So this would be pi. So then my scaling, that's the word I've been looking for the whole time. The scale, or the increment, would be what?
Pi over 4.
Yep, pi over 4. And then any shifts?
Yeah. Yes.
What are they?
It's like pi over 2.
Right, pi over 2. Down 1. And anything else happening to this one?
It's reflected on the x.
Is reflected.
So when you're graphing, would you do the reflections last? Like after you move it up and down?
I actually usually go ahead and do my reflection first. I'll show you with this one. If you feel like you can't, I would definitely reflect before I shift. Because I feel like people tend to get confused with when the graph gets shifted, they get their midline confused, and then they get the points where they're supposed to be in the wrong spot. I'm going to go straight up with reflecting this one first so you can watch me do one like that. But if you need to graph, then reflect like we did in the one earlier that just was a reflection, you can also do that. Okay? So, I'll set this up here so we can see it. I know ultimately I'm going right pi over 2, so I don't really need anything left of 0. So I'm just going to go ahead and set this up pretty far over this way. So I've got scaling of pi over 4. So I'm going to set this up. I know I'm going right pi over 2, so I'm going to make sure I put some extra spots on here as well. So past pi, I'm going to go to, that would be 5 pi over 4, and then 6 pi over 4, which would be 3 pi over 2, would be my next thing there. So this is also where the counting that we do with our unit circle can be a little bit helpful as far as that goes. And then I'm going to put the values up here. So this is 3, 4. I'm going to go all the way up to 5 because I know I'm going, oh, actually I'm going down 1, so I kind of went in the wrong direction. 3, so. Anyways. Now, it's obviously 3.5 is the amplitude, so I'm going to have to go a little bit past that, but I'm just putting the marking for 3 on here. All right, so this is sine. Where does sine start?
At the X. I'm at origin.
At the origin, and then it normally goes up. Okay, if I'm going to do my reflection initially, I'm going to start at the origin still, but I'm going to go down. So at pi over 4, negative 3 is my next point. Now,
I thought it was 3.5.
thank you. It is 3.5. This is what happens when I don't put the markings on there. There we go. All right, so then I am at pi over 2 and 0. Okay, it's going back up. Then it's going to go up again, 3 pi over 4 and 3.5. And then back down to pi and 0. Okay, so this is included my reflection. So I would at least reflect before I shift, if nothing else. If you feel like you need to do the parent function first, that's fine. I would very much caution you from doing everything in one step because people tend to get them wrong. But anyways. So then at this point, I would do my 2 shifts at the same time. So it's going right pi over 2, which notice just like the one that we did earlier that was shifted, that means it's actually going over 2 spots and then down 1. So my one at the origin is going right pi over 2, down 1. This point down here is going right pi over 2 to 3 pi over 4, down 1. This next point that's back up here on the axis is going right pi over 2, down 1. This next point up here, right pi over 2 to 5 pi over 4, down 1. And then my last point here at pi, right to 3 pi over 2, down 1. And then, again, just make sure that we draw it correctly. So this graph in red would be my final graph there. Any questions about that? All right, so I'm going to go ahead and give you some problems. I'm going to specify which ones I want you to actually graph. You'll have time tomorrow to work on these, probably like 25 to 30 minutes, and then we may start looking at one of the word problem things tomorrow. We may wait till Thursday. We'll see. Or we may actually go ahead and hit the tangent graphs briefly tomorrow at the end, because it'll take us about 5 minutes to do the tangent graphs. So, problems with this: 1, 9, 19, or not 19. Wait, is that the one that? No, 15. Sorry, I was looking at the wrong problem. 15 is the one that you also have to do frequency for. If you want to do it on the other ones, you can, but 15 is the one that you need to add frequency. And then 61, 63, and 65. These last three, you actually need to graph those ones. Okay, the other ones you do not need to. So, as far as parent function graphs, part of your next quiz is going to be to graph all 6 trig functions. Okay, sine and cosecant go together. Those can go on a graph together so that you're not having to do them. Cosine and secant go together, so you can do those. Tangent and cotangent both have to get their own because their asymptotes are different on those ones. So that's something you can be studying anytime now. The only other trig function that we're actually doing anything with as far as finding its values is tangent. But they don't really ask you to actually graph tangent, as long as you understand like what's happening with like its asymptotes and its period of the tangent function. You would be able to match that with any of the graphs that they give you if it was a multiple choice type question. So we'll probably very, very briefly hit that maybe tomorrow at the end, because like I said, it'll probably take us 5 to 10 minutes and we'll be done with that. I may change my mind depending on how long this stuff is taking y'all, but I really don't think these 6 problems are going to take you very long to do. So, any questions about anything? Is this about this, or is this like to go? Yes, I can give those back actually.